Hi, it's David. I'm going to try to go over 2.23. 2.23. So this had to do with identities, and I just want to be sure that we've got a basic understanding here. Order of operations keeps sneaking up on us, and I want to be sure that we understand how to handle that, okay? So a couple ways to do identities as we discussed. I could plug and chug some values. Please remember, you need to plug and chug at minimum 3 values before you even feel 90%, 99% sure, somewhere in there, So that's key here. Let me just see if I can practice by doing one value. Many students plugged and chugged x equal 1 when I looked at the homework. Let's take a look, okay? So on the left-hand side, 2, 1 plus 1 squared. Does that equal, question mark, 2 times 1 plus 2 squared? Okay, so let's see. On the left-hand side, order of operations, people, PEMDAS. Got to keep it clear. You ready? The inside first. Technically, when you say parentheses, it means inside the parentheses, but we don't say PEMDAS. I don't know why. So now it's 2 squared. Exponents first. And we have 8. Over here on the left, 2 times 1's 2. Inside the parentheses gives us 4. 4 squared is not 8, it's 16. So right off the bat, I do not believe this is equal. If you were to do it via algebra, then you want to look at the left-hand side and the right-hand side again. The left-hand side says 2. You cannot distribute in there. Can't tell you how many students wanted to do multiplication before exponents. That's why we made PEMDAS. Please keep it straight. When you see something like this, you should be seeing 2 times x plus 1 times x plus 1. That's what this is implying. There is not a 2 distributed. The other side, we're asking if it's the same. Well, it's 2x plus 2, 2x plus 2. And no, I'm starting to believe that it's not the same. Okay, I can multiply this all out, but I could also do a first term check. Look at this. First term, 4x squared. First term, x times 2, not 4x squared. Cool? Please, order of operations, do not treat it lightly. Too many of you are going to mess up on simple SAT questions if we don't handle this well. Cool? All right, here, let's try another one. I have to compliment. I just want to compliment. So many people said, multiply by x on both sides to blow out the fractions. Thank you. Thank you. So there's really not much to talk about here. I either heard cross multiply. A lot of students wanted to make it 5 over 1. I think that's awesome. Good for you. Okay. Cross multiply will get us out. But I also want you thinking in a more advanced way. There's only one denominator. It needs to be canceled. If we multiply by x on both sides, it'll do the job, and you'll see that it's the same as cross multiply. Please be careful. Please be careful. Okay? I can't cancel anything here because there's not a multiplier here of all factors. This plus sign kind of ruins it. So I couldn't cancel a 2 or any 2s or 7s or x's. Be careful here. Proper answer, cross multiply, but my preferred, more professional answer is BOF it by multiplying by x. Last one. I had several students actually say for several reasons that this is true. Okay? We plugged in chug 0 and you found it to be true? Yeah. You plugged in chug -2 and guess what? It would be true. So there were some little, mistakes along the way. First, let's verify. Let's just verify. Okay? So if I took x equals 0, I would have 0 to the 5th plus 32. And on the other side, I would have 0 plus 2 raised to the 5th, which is 2 to the 5th, which is 32. Yes, x equals 0 checks. Perfect. check x equal -2. Cool. -2 to the 5th. Good to practice this. That's 5 negatives. Again, there's a lot of foundational stuff that's got to be clear here before you move on to pre-calc, okay? That -2 times itself 5 times is 5 negatives and 5 2's multiplied. It's -32. Cool? Keep that in mind. The rest of it was plus 32. So plus 32. This is 0. On the other side, if you look at x plus 2 and you ask what makes 0, then -2 makes 0. And even if you took that to the 5th power, it still makes 0. So first, these two do work. You can't say no to this problem because you think these don't work. These do work. But it takes 3, simply 3, just 3 numbers before we even start to believe this is true. I'll just check x equal 1. It's always a nice simple one to do. And in mathematics, we often check 1 and 0 to see where we are. Is this even possible? Hope this is making more sense. Let's plug and check 1. Cool. That's 1 to the 5th. That's 1. 1 times 1 times 1 times 1. Plus 32. And the question is, does that equal 1 plus 2? That's 3 to the 5th. So this is 3 times 3 times 3 times 3 times 3, right? Right? That's going to be pretty big, right? Is this equal to 33? No. So that would have been a good way to get full credit here. Just say, no, I checked x equals 1. We don't have to investigate further. Another way to think about this is my poster mistake. Do you remember that misconceived identity? A plus b squared is not equal to a squared plus b squared. Well, guess what, boys and girls, ladies and gentlemen? This works for all powers. So you want to know something? X plus 2, by the same rule, is not equal to x to the 5th plus 2 to the 5th, which is what they're trying to get you to say. So again, that's that sneaky poster mistake I had up behind me. Remember that? Right? We still are getting suckered into it. How do we see this to be not true? Because the reality is, I'm not going to lie, this is x plus 2 times x plus 2 times x plus 2 times x plus 2. I'm running out of room. And if I multiplied all of these x plus 2's out, guess what? The first term is x to the 5th. Look, x to the 5th. First term, my rule still rules. Still rules. Okay. Last term, 2, multiplied. Yep, 32. But here's the catch. There's a bunch of middle terms that are missing, just like this one. Because you want to know what it is equal to? It is equal to a squared plus 2ab. Remember I told you about that trick this week? I just double after multiplying the two little parts, right? A and b, and then the b squared. So guess what? There is a bunch of middle terms in between here. And it's kind of cool. There's a neat rule for it. It has to do with Pascal's triangle. Oh, look up Pascal's triangle. Such a cool pattern. You'll love it. Well, I'm David, and I just wanted to help you make sense of this homework, but more importantly, I wanted to be sure that every one of my students has had a thorough review of your basics, misconceptions. Okay? Please, let's recap. That poster rule works for all size exponents. Cool? This one, be careful. Don't cancel anything. Nothing there can be canceled to start off this problem. And use BOF style, blow out the fraction style. It's kind of cool. This one scared me the most, boys and girls, ladies and gentlemen. Please, that 2 cannot be distributed into there. Why? Order of operations says square first. Okay? I'm David. I hope this is helping.